Service providers and enterprises are challenged in all directions to accelerate time to revenue, to deploy and operate new services with zero defects, and to offer intent-driven customer experiences. A software-driven network automation approach is the only viable solution in this Internet of the future. Cisco Network Services Orchestrator, the industry leader in trusted, highly scalable orchestration, helps to unify developers, infrastructure, and operation teams to capture the economic benefits. Simplify network and service orchestration across a multi-vendor, multi-domain environment and eliminate 90% of manual tasks to produce fast, reliable results. Let's see how. New services can be created with a tool like NFVO. A new provider edge service can be defined with firewall and custom QoS policies in minutes. Enhance the offer with an assurance application by simply dragging and dropping into a service chain. Add or enhance new items in your service catalog to meet your customers' goals. Deliver on a new customer order using NSO to create a new instance that is right every time. Using a Yang model-driven configuration, the provider edge service is provisioned as you monitor the sequence. In minutes, you will see the service fully operational to support live customer traffic. Distributed customer locations can be provisioned using flexible templates that minimize changes while delivering their intent. Activate your customers by translating to native configurations. NSO supports the broadest range of multi-vendor devices. Service Manager Check Sync function enables assurance teams to check the configuration meets intent. Check Sync confirms an error has occurred. Dry Run identifies required changes by comparing the current configurations against the template. Redeploy enables operation teams to automate the repair tasks. Check Sync confirms the remediation is complete. A dashboard gives the operation teams real-time visibility across their multi-vendor, multi-domain infrastructure. Check Sync audits your mass-scale network for compliance, and Compare Config identifies discrepancies. Recalibrate from gold configs or device configs to keep your records accurate at all times. Automate your deployment pipeline from dev test to deployment to daily operations and optimization. Integration with Cisco Crosswork unlocks closed-loop network automation to improve mean time to value and repair. A rich set of software interfaces yields easy integrations with existing toolchains, OSS, BSS, Cisco DNA Center, and application-centric infrastructure. Cisco Network Service Orchestrator serves as the foundation to automate in a world surrounded by 5G, IoT, and cloud. Empower your organization now with the agility to realize operational excellence that prioritizes your customers first. Automated, intelligent, simple.
Cisco, the bridge to possible.
Good evening or good morning, everyone, wherever you are located today. Thank you for joining our first Virtual Developer Days meeting. This is the second day, and it's a great honor to have you all. So my name is Nicklas Wagerth. I am the NSO Community Lead. I'm also responsible for the ecosystem strategy, including NSO Developer Hub and NSO on DevNet. These are two great resources that you can use to start getting started with NSO and engage with the community. So with me here today, I have Jan Linblad. He is one of the NSO experts and a true community champion.
Thank you, Nicklas. I'm supposed to discuss with you or tell you how important it is that we share our wins, that we make this a dialogue rather than some sort of webinar. But from the experience from yesterday is that we need to show you more hands-on how to use the Cisco Events app so that we can make this a truly engaging and experience much more than just a webinar. So let me switch to my phone here and I'll show you. My iPhone here, I can go to the Cisco Events app. You need to download this in order to participate fully in this event. So download the Cisco Events app and start it. And we'll start something with a menu of all the different Cisco events across the world. And you need to log into this NSO Developer Days virtual event. If you have used this app before, you might be logged into Cisco Live or something like that. And you need to log out of that in order to see this menu. Then you click on this NSO Developer Days app or section, fill in your email. And then your secret password. This is the confirmation code that you got by mail on Friday and maybe this morning too. That gets you to a sort of main page like this. You hit the 3 bars up there, you get to the menu. First thing you want to do is go to your settings here and make sure that this top item here, opt-in for attendee list, is checked. As you can see, there are some push notifications coming on. So if you have the app running, you will see what's going on here. Some new session is starting, or there's a poll question coming up, or something like that. So it's good to have this open. And then here in the menu, you can see if you opted in to be visible, then suddenly you're in the list of all the attendees here, which means that you can connect and be connected by other people. What I wanted to show in particular, here's the activity stream. So where you can just post comments and photos and whatever you want about this event, in order to make this a little bit more social than just sort of you listen to a webinar kind of thing. And the most important of all, perhaps, is this. If you go to the schedule here, you can see the schedule for both days, 23rd and 24th. And if you go into one of these schedule items, you get some information about what this is. But in particular, you get to the polls and to the chat. And here in the chat is where you ask questions. Then the moderator for the particular session you're in will look here for questions that you are asking and read them to the presenter. We are a little bit too many so that you can unmute yourself and speak yourself. So instead, go here to the chat section for your particular section and post a comment with a link down here, and you can fill in. This is moderated, so it takes a few seconds after you type something before it shows up for everybody else. So give it a minute, but then it should be coming up. So please, to make this interesting, please use the app and let's collaborate and make this a two-way conversation rather than just a webinar. And with that, I'd like to hand over back to Nicklas.
Thank you, Jan. Good explanation. So just to quickly repeat here what we can expect today. So the first section, which is right now, we have 3 wonderful speakers. We have 2 sessions on-demand reconciliation, and then we have an update from our product management. So after this session, you're expected to click on the green symbol, which says choose live track, and enter a WebEx meeting. When that is finished, you have the on-demand content that you can consume. And after that, of course, you can fill out the event survey. So with that, I'd like to hand over to Teruhisa Tajima from Entity Communication. Enjoy.
I'll talk about how we operate NSO for our laboratory network, especially synchronization between real device config and CDB state. We have to solve this synchronization issue because we change configuration and topology by our hands, not only NSO provisioning. Today, I'll share our trials. Before I start to talk this topic, I'm going to introduce our company and myself. Our company, Entity Communications, is one of the largest ISP in the world. We develop and operate many circuits, data centers, servers, applications, and so on for business and consumer customers. My job is research and develop about new networking features and operations. Okay, let's start talk about NSO. Before talking our trials, I show you the typical data flow of making configuration in NSO. NSO developer define abstract model describing what my service is. Operator or other system modifies that service config. When someone changing service config, NSO translate it to device config and deploy it to real switches and routers. In device config storage, ref count is a counter, which is how many service config depends on each device config. The counter is an important concept in my trial. NSO increase or decrease this count when translate service config to device config. And using this count, NSO determine whether the setting should be currently in place or not. I'll mention this ref count later. So at almost all projects, especially in greenfield, that's all. Because operators will use only NSO terminals or API to control their devices after have deployed their system. The data stream one direction. However, we are not such project. In typical migration from brownfield, once we have built service config from device config, the migration is completed. After that, operating service config is only way to change network, same as previous example of greenfield. But in our environment, we want to change config manually outside of NSO, such as this figure. Some operators modify service config, and at the same time, the other operators modify device manually. We named it blowing brownfield. There are two reasons why we want this. The main reason is considering balance of implementation cost and its effect. To implement logic about rare and difficult operation is complicated and its effect is limited. So we want to avoid this implementation cost and we decide to use our hands in such difficult operation. We often change topology and integrate new equipment and features. So we think this balance is important point of automation tool. We also considered about balance in NED. We try to develop NED for training, and we use handmade NED, but it doesn't cover full capability of network equipment. The other reason is engineer training. We usually use our network to on-the-job training of our team members. And we want to know how to develop and operate NSO. Our trials is in such situation. In this presentation, I'll show you two key benefits. The first is we define multi-vendor topology service model to change topology after deployed NSO. The second is we sync status between NSO and device C by using redeploy and reconcile after the manual configuration. In the beginning, I explain a use case. This is an example of changing topology drastically. This example is what we actually did in this March. We often change our network topology because of circuit outage, integrate new equipment, or other reasons. In this case, we aim to resolve cascade connection which cause narrow bandwidth and change circuit. So we want to change the topology from left side to right side. Before this operation, switch A, B, and 1 to 4 are operated by NSO, and we were going to insert switch C and 5. This is 3 operation steps in this work. The first step is insertion of switch C and switch 5. It is done before changing physical connections. The second step, changing cable connections. The third step, configuration of NSO. We clear unused connection and set ref count to correct value. The first and the second step is trivial. I'll describe the third step. The third step, post-configuration, is equal to NSO maintenance. In this step, we set physical connection correctly. As I said before, we did 3 operations to set ref count correctly. This figure shows physical connection and CDB state. Before we start synchronized status, CDB config shows incorrect topology. So fit service config to physical connection. And redeploy with no networking. This command does not affect any configuration of real device. In this phase, CDB config shows same topology, but device config status is out of sync. We did sync from and match CDB config to device config. In this phase, each line of CDB device config has incorrect ref count. To resolve ref count, we did redeploy and reconcile. Finally, we got in-sync CDB status. The downside of this strategy is that it takes a lot of time. Each commit takes a few seconds to tens of seconds. We did this operation through about 8 hours with scripting. To achieve such operation, I'm going to talk about these 2 topics. The first topic is service model implementation. We try to orchestrate our lab network. Our network consists of some vendors and some vendor switches and routers. I'll show you an implementation using Augment to abstract service model. The second topic is sync configuration between NSO CDB and devices. I'll show you how to resolve inconsistency these states. Let's start first topic, service model implementation. I'll describe our route to develop service model. We have some data center racks in metro area. In our lab, some project members test feature or operability of many network equipment. And also, sometimes our lab network is testing device. In such our lab, our network provides layer 2 VLAN connectivity. Our network consists of some VPN circuits and over 100 multi-vendor switches and routers. They are part of vendor list we operate. When we implement our network service, we develop the following 4 components. Especially service discovery is translate logic from device config to service config. We also develop NED because there is no driver of some national vendors or old operating systems. I'll show you how to define topology in our service model. Our lab network is providing end-to-end layer 2 VLAN connectivity. We need to calculate connection path in CB create. For example, in this topology, we want to connect from switch A port 10 to switch C port 20. We divide this connection to how to calculate intermediate path and how to store the end port. Because in normal operation, without changing topology, we operate only the end port model. In order to configure all intermediate transit switches, we have to list up all switches between switch A and C. We want to know how each switches are connected. We define this service model of physical connections. It stores which switches and each port is connected to another switch. Of course, switches and routers are registered as a device. We can use Young model validation. From this data, we can calculate shortest path between any two switches. Next, we define endpoint model. This is an implementation of endpoint model. It seems very simple, but this model is difficult in multi-vendor network. In multi-vendor network, how should we define endpoint leaf correctly? The problem equals to how to describe this one port in Young model. Each vendor has different model, so we cannot define one leaf in Young, such as a leaf ref. It seems there is some strategies about this problem, but we use augment. Using augment seems the best choice to implement such model. In this strategy, there is an empty container in service Young model to inject each vendor model. And in each vendor model, it defines augment model. Upside is many things: suggestion, complement, validation, and easy to add new vendor. When we add new vendor, simply we add another Young model file. Downside is almost nothing. This is an example service config of using augment. The service config shows some vendors, and each vendor model is separated into each files. Next topic is how to resolve inconsistency between NSO and device. What is the inconsistency? Here's one situation that someone changed device manually. First of all, service config, device config, and devices are synced with commit A. At some point, someone changing device manually with commit B. And another operator tried to change service config with commit C. But this operation will be failed because device state is different from device config. If we do this operation, need to solve this inconsistency equal to sync device state to NSO CDBs. Here is another situation, changing topology drastically. It is when we change left side topology to right side topology. Once you start operation with NSO, you need to consider the difference of before and after state. But it sometimes becomes difficult question by changing size. To avoid this question, stopping calculate the difference. We should rebuild service config from current device config after changing topology. I'll show you service discovery step and ref counts. Service discovery means rebuild service config from device config. We implemented this service discovery is an action. This figure shows each configs after done service discovery. Service discovery reveals service config. Each line of device config has left count. And in this situation, it has hidden one count. This count is originated by real device, and unfortunately, it doesn't show at the show command. Next, we do redeploy. Each configs are independent if only service discovery. By trying to deploy service config, redeploy recognize which service config generate which device config, and make a relationship between service and device config. then ref count is increased. But it is not complete, still has hidden ref count. Finally, we do reconcile. Reconcile check each device config is generated by service config and clear hidden ref count. After we do reconcile, device config status, especially ref count, is the same status as deployed it only by NSO. So if we delete its service config, the related device config will be deleted. Of course, we consider another method. There are two examples in this slide. How about using partial sync to and from? It seems to work well if partial region is defined easily. For example, one service model affects the limited number of devices and limited hierarchy of configuration. But many cases are not so. We should use sync from for configuration. How about using NSO at all situations? I think this is not a good idea because there is a lot of type of operations what sometimes happen to what often happen. And such rare case needs careful logic and cause big impact for networking. So classifying by operation frequency, if the operation happened many times, then fit to NSO. Although if the operation happened few times, do it by hand and sync NSO. This story is our trials. This is conclusion. Our case is not fit to NSO standard users, but in such case, we searched efficient operation with NSO because we want that automation tool will release us from boring routing work. And we acquired two skills. The one is implementation using Augment. It provides us easy deployment in multi-vendor environment and easy operation of changing topology. The another one is controlling ref count. It provides us both operations by hand and by NSO, and it prevents us from implementing difficult and rare situations. Unfortunately, I think there are not many cases which our system will be fit, but it shows a part of NSO capability. Thank you for listening.
Thank you very much, Teruhisa, for a great presentation. All right, so this is Hiro from Cisco. So I would like to move on to the next one is a live Q&A session. So whoever has any questions, feel free to put your questions on the app that Jan explained at the beginning of the session. And I already got the couple of questions, so let me start with that. So Teruhisa, we have him here as well. So let me ask you the first question. The first one is, how did you run the system which you shared in the session? So could you take the question and give us the answer? Yes. So Teruhisa, it would be good if you could talk louder a bit.
Okay. Can you hear? Sorry. The answer is, I said the answer. We do this system in two ways. One is shown in this session. We use step by step in large maintenance. And the other way is daily cron job. In our network, most of changes are small, so cron process can do sync from service discovery and redeploy in early morning. After that, operators check its results.
All right, thank you. And I got more questions, so let me move on to the next one. The next one is, did you have any issue by working with multi-vendor devices, especially CDB migration?
We didn't encounter such CDB issue. I think reason is that each of the models namespace are dedicated. And I'm trying to upgrade NSO version from 4.7 to 5.3. Upgrade trials, there is no problem. But I don't know what issue happening in NSO when they reach some models, because we did not do that.
Okay, thank you, Teruhisa. So if you could talk a little bit louder, so that the camera switches to you. Okay, and I got more questions coming on the app. Next one is, you talk about the new topology stuff, but did you consider the IETF topology model?
No, we didn't try. So we did try and error to implement model due to training or thinking models. So we didn't consider it.
Okay, thanks so much. And let me move on to the next one. I got many questions here. The next one is, on these days of COVID-19, how to reduce time cost, under this COVID-19 situation. Do you have any comment on that?
I'm sorry, I don't enough idea.
Okay. Thank you. All right. And the next one is, so do you see any errors by working with manual operations? So if so, how do you handle that?
So the operator tells our DevOps team, and we started troubleshooting. Most of errors are caused by ref cons. For example, operator delete configs which still has ref cons. We try to delete it with no networking and commit and try sync from.
Okay, it's good here. That's handled by the operation team. Okay, so the next one is regarding the performance. I have the similar questions, multiple questions, but what is the performance? How fast the commit was?
Unfortunately, each commit takes tens of seconds or a few minutes. Indeed, we can tune commit speed, but we prefer manuality of code because in our environment, its time cost does not matter.
Okay, I understand that it takes tens of seconds, and since it's in your lab, you don't care the NSO performance actually. Okay, so I still have some questions, but unfortunately we are running out of time. So let me take the rest of the questions offline and then move on to the next one. Thank you very much, Teruhisa, for having the very good sessions and attending for the live Q&A session. Thank you.
Do your operations and engineering teams feel that your network is becoming exceptionally complex? Is troubleshooting the root cause of issues consuming too much OPEX? NetRounds REST and NetConf Yang API make model-driven orchestration from Cisco NSO straightforward. Become proactive by including active assurance into your lifecycle orchestration processes. Automatically test and monitor networks, clouds, and services to ensure healthy network performance.
Hi everyone. Good morning, good afternoon, good evening. Myself, Girisha Bokanakire. I am working as a CX engineer for SAO team based out in Bangalore. I am currently working for Bharti Airtel automation project from last 8 months. We are going to discuss about reconciliation topic today. Today, we are going to discuss about the reconciliation for the huge network. We haven't done till today, right? We handled it for 100K, 150K, 200K max, right? In a Bharti Airtel network, we are going to reconcile 500K services, right? This is quite different than other reconciliations because of the scale. We'll discuss about the agenda of this slides. So we'll discuss about challenges first and what is the adventures we gone through to come up with this solution. And we'll discuss about how the ODI framework looks like and how the workflow looks like and what is the success story from customer as well as Cisco. Certainly, we have to think behind our limitations, right? After implementing some of the success stories, we will leave with some of the limitations. We'll discuss about that. Finally, we will enter into the question and answer session. So this is basically a challenge which we have, right? It's a huge network, pan-India coverage, right? There are around 500K L3 and L2 network services across India. This is built over 20 years, right? Many team, many people, many managers involved, and it's basically a heterogeneous network. We have a large variations of services because if I take an example of MPLS L3, that itself is a 300K services. 300K services has so many variations in it, in terms of routing, in terms of QoS policy, in terms of managed mode and unmanaged mode, right? As and when we started doing the discovery and reconciliation, this is basically an insightful journey to the customer as well as Cisco. Because it's not just about finding any deviation, we are finding some variations which was not part of our standard service. So other big problem with is like critical operations team always go and touch the network. We can't avoid them because they have to serve their customer. It is unavoidable for any customers. We can mitigate to certain level, but we can't make it like 100% free of touching a network. Right? So basically, we keep fixing any deviations. We keep doing the discovery and reconciliation. So since there are manual activities involved directly in the network devices, certainly they may add some more deviations into network, right? Basically, that is where I told it's a growing elephant, right? It doesn't stop, right? When it will stop? When they stop touching a network device directly, right? So there is a common phenomena with the customer and the people who are like very new to the NSO. They think, okay, there are 300K services or 500K services. It's like, why are you taking that much time? Like, that's their question is like, in order to create 300K entries in the database, you may take half day or 1 day, it's fine. So I wanted to clear it off to the customer. I clarified to the customer, many stakeholders. NSO is not a relational database. It is much more than that. It is actually an integrated config DB, right? It doesn't just create an entry of the database and move away. It has to create a database entry. Along with it has to create a relationship with the device model, and it has to make a ref count. It has to create a back pointers. It has to run its own fastmap algorithm to create all the integrated data, right? There are some limitations, right? It takes much more than whatever RDBMS takes, right? Because it's not a RDBMS mean to be. It's like it is a config DB. Right? These are all the current challenges with which we started with an adventurous journey, right? So we started with the MPLS L3 services. They're actually around 300K in count. We did a couple of discovery and reconciliation in our non-production environment by taking all the device tree backups. We started doing that. We ran a couple of data activity for the MPLS L3 network. We found 50% deviation in the first place, right? We went to the customer saying that, okay, we could able to reconcile only 150K of the services. We weren't able to do it for 150K because it is out of standard. Whatever the standard we defined, whatever the standard we discussed, and whatever the standard we created in NSO, these data is deviations from them. Right? Let's say it's like, is it all deviations? No. That is where I told it's an insightful journey to the Airtel as well as Cisco. As and when we discovered complete network, they also started understanding, okay, there is a variation. In some cases, we don't put out policy. In some cases, we don't put in policy, right? But in a standard service model, it is all mandatory. Right? Basically, this is in a journey wherein which we negotiated again with the requirement, and certainly we make the certain conditions, okay, in and out policy is not mandatory. Right? This is just an example. There are so many variations like that. Let's say like out of 300K, there are 2K, 3K services like that. Right? There are so many variations, like 10 variations, it will add up at least 30, 40,000 into a reconciliation world, and we have to adjust our service model. Right? Certainly after adjusting something and they corrected something in the network, we reran one more time. That reduced to 41%, right? 41% deviations and 59% successfully reconciled. Right? Still we left with 41% deviations. Again, it's like there is a discussion started. These are the deviations in the network. You have to look after. Again, customer told, okay, these are all the certain variations. And then we adopted in our service model. Fine. Like they corrected something in the network. Fine. We run for the third time. That reduced to 29%. It's a really huge achievement. It's like we reduced to 29% now. Another way, it's like we are left with 29% still. How many more runs we can do with this? Right? How long NSO takes to rerun? Right? That's the question the management asked. Cisco management as well as the customer management. How long it will take to run the complete 300K reconciliation? Right? I said to him 6 full days. Why 6 full days? You are talking about 144 hours to rerun complete network again? We can't live with it. Right? It's a tough question. I mean, I wanted to quote when we did the reconciliation for the first time, it took 31 days because as and when we create normal service for the normal provisioning and normal CRUD operations without load, everything seems to be fine. Everything works fine. So NSODB started filling with the service data. There are so many lookups which we use across the service tree and other things. So we have to mitigate those problems, those lookups, and we have to do some external lookup, everything. And there are some resource manager dependency, right? Let's say it's like resource manager started using it up to 40K services creation. There was no problem. Started a bit slow after 40K. Then after 80K, it's a bigger slow. It's like it was taking a single call for the resource pool. It was taking 8 seconds, right? 8 seconds is a huge time in this network, right? If it is normal provisioning side, there's no problem. Even though you're taking 40 seconds, 50 seconds to put into the devices end-to-end provisioning flow, there will be no problem at all. As and when we are doing it in the bulk, each and every fraction of second matters, right? We mitigate all the problems. We bring down to 6 full days of run. Finally, how much time we are taking per service? It is just 1.7 seconds, right? When we talk about 6 full days, everyone is, okay, they are going to take 6 full days. I have to completely stop my production activity, right? Basically, ultimately, I'm going to take 1.7 seconds to reconcile both primary and secondary services. This is like joyful journey we had with the customers like for almost 2 months, right? Then customer told us like, okay, we are left with 29%. It make in another reruns is a couple of reruns, it may come down to a 10%. Right? You have to leave it at it. It's not something like you can close it immediately, either from the customer deviation perspective or service adjustment perspective, right? This is where the on-demand reconciliation framework is all about. So we have LSA architecture, NSO CFS and RFS layer. Basically, it has different RFS layers. I am illustrating just one RFS layer over here. So we have 5 RFS layers, in fact, right? We have a BPA running on top of it, right? And we have a customer OSS BSS system, and BPA has its own UI to do the change management, right? Ultimately, what is the use of reconciliation? It's like why we are going to do the reconciliation in the customer network, right? The ultimate goal of doing the reconciliation of the customer network is to support a chain management and permanent disconnect management, right? That's the primary goal of doing a reconciliation, so that as NSO, we can support end-to-end CRUD operations. The another primary reason of reconciliation is to use NSO DB as a network inventory for them, right? So there are 2 reasons. That's where we go for the reconciliation. In this specific case, how we are designed is basically predominantly for the change and disconnect management. Either customer can push change order for a particular circuit, either from the customer OSS BSS system or from the BPA UI. Right? So it enters into the BPA core. We have an external DB API. This is basically a separate application, keep running, and it periodically query the device data. What kind of device data it queries? I wanted a data where exactly this service currently running, in which device it's presently running, right? There are so many circuit movement happens in the network because of so many reasons. Let's say it's like the server is heavily loaded, the backend team will come, the operation team will come. They eventually move all the services from that router to another router. And there are cases wherein which this is a pan-India network, right? They have customers ranging from a small customer, medium customer, and the large customer. A small customers might keep moving their office location from one location to another location, right? They have to move the endpoint from one location to another location. That's another reason of moving a service from one router to another router, right? It's keep happening in the background. We can't avoid it because they have to serve the customer as soon as possible. That used to happen all the time, right? For that reason, we kept an external DB. This is periodically runs every 2 hours once on all the devices, all the intelligence devices, which are running in the network. So it queries the data of in a circuit where exactly it resides. One is the primary router and the secondary router, right? As and when there is a change and disconnect management enters into the BPA core, what it does is like it invokes an external DB asking where and all this particular circuit is running, right? Irrespective of whether that circuit is already reconciled or not. We don't know, right? Even though it is reconciled 3 months back or 3 days back, right? It might have moved to a different router altogether from last day or last month. So basically, we can't rerun the reconciliation again and again because it takes a huge amount of time, right? The next slides will show the complete picture of a workflow, where exactly the flow gone through. Is like there's a OSS-based system. This starts within a change or disconnect management for a particular circuit. It doesn't tell, okay, you do the ODR for this particular circuit. It does normal change management and disconnect management, right? What BPA does it like, it goes to the config DB, takes the data, right? How many devices this circuit is done with, right? Then BPA processes internally the data which is coming from the config DB. Okay, good to go. Then what it does is like basically delete the existing circuit from NSO, and we call in a ODR. ODR is basically we are calling on a specific routers for a particular circuit. It may take is like 10 seconds, 20 seconds, right? Once we discover the complete data, either it end up in a deviation or in a created circuit, in a proper standard circuit, right? If there is deviation is coming in, so we returning back to the OSS-based system. We don't do any handling of the change management at this point in time, right? The NOC engineer who is sitting there, network engineer who is sitting in the OS-based system, will get a deviation data. Okay, this specific circuit has some deviations. I have to fix it in the network. Right? This is basically we are providing a flexibility to do it in on-demand basis, right? Once, if there are no deviation, then reconcile the circuit from the NSO CFS to RFS and it's like create all the entries in the device tree. Basically, apply the change or a disconnect management on top of the latest circuit. Right? That will be applied onto the direct device and returning in a result. If there is an error, it will be returned, or successful results will be returned. So we are going to talk about some of the success stories, what we achieved for Bharti and what we achieved ourselves as a Cisco, right? We talk about the customer success stories first. We provide a time flexibility to adopt network deviations to them, right? You do it your own time as and when it is required, right? If you're doing it upfront, we are good, right? As business needed. It's a big relief for the customer. Okay, I am not supposed to stop everything to do this deviation fixes, right? So there is a certain advantage. Like there are some new service variations we discovered while doing the entire activity that can be adopted very easily, because whatever the logic applied the last time, before making any changes to that circuit in a network or before removing in a circuit from the network, we're actually adopting in a latest reconciliation logic which we are applied on the NSO server, right? Change should go via NSO BPA automation. Yes, certainly we have to go in this path to bring in a complete resiliency in the network, right? If we have to standardize the network, it should happen, right? Basically, the streamlining will take some time because there are so many teams, so many people are involved in the customer operations and provisioning team, change management team. Right? Certainly, they can start doing it from the most happening cases. What is the most happening cases like from the UAT front? It's like provisioning, right? They wanted to do the change management, they wanted to do the basically provisioning of a new service, permanent disconnection. These are all the things they keep doing it, right? There are some additional features. It's going to come with its own timeline, right? So let's talk about the Cisco success story by adopting this. It's all automated now, end to end. It's basically geared. If there are any recon bugs, it's like software tend to have bugs, right? We can't have 100% bug-free software in first cut or second cut, right? Other use cases, delivery timeline doesn't change, right? This is what I was talking about. There are some service audit feature, right? That has its own delivery timeline. As and when we don't adopt this on-demand stuff, they would have pushed us to finish that one before going for the UAT or the live of the system. Less chances of outage because we are always going and checking the latest copy of the data from the network before applying a change. It's just a matter of 10-15 seconds delay between reconciliation and applying changes, right? That's the minimal gap which we have. That's a big relief for us. Like wrong config push doesn't happen. This is one of the success stories. These are all the success stories which we have as a Cisco. Certainly, is like we achieved some of the things. There will be limitations, right? Only in imagination, there will be no limitation, right? NSO certainly can't be used as a real-time service inventory system in the realistic world, because as and when there is a out-of-band changes keep happening, always there will be a disconnect between the NSO and the real network which is running. That's one of the limitations. The other limitations will be increasing the. There are corner cases wherein which I was talking about the external DB, right? External DB can't query like in the real time. It takes its own time, right? It has, in order to find in a particular circuit in a real time, it has to go through like 1,000 devices. Right? That's impossible. What we do is like there is a cron job running every 2 hours once, right? Basically, so within that 2 hours window, if you are doing multiple shifting of a circuit, right, one router to another router, that's one of the corner case we can't support. There is a requirement of additional relational DB because we don't want to do that extra burden with the existing NSO system, because every 2 hours it runs and keep updating, right? While updating is like whatever the customer orders keep coming, that will be piled up, right? We can't process both customer orders as well as this cron job together, right? We have own limitations because we have only one write thread at a time. So basically, this addition, along with the additional relation DB, every 2 hours it's going and querying the device. It's read-only activity. It doesn't do any modification to it because still it little impacts the device performance, right? And the last limitation would be like is kind of a double-sided sword. Like deviation fixes and the reconciliation code changes becomes continuous. You can't stop them anytime soon until unless everything adopted as soon as possible. Right? We provide a flexibility. Within that flexibility, every utilization is proper. It's okay. I mean, if it's over-utilized, it's like even though after 2 years, okay, we don't worry anyway. On-demand reconciliations keep running. Right? Ultimately, that increases the change and disconnect management time, as well as this becomes an habitual continuous changes to the reconciliation code as well as the deviation fixes. Right? Yeah, that's all I have. If you have any questions, you can now.
Thank you, Girisha. There's a good presentation on a very interesting topic. And I'm sure there's a lot of interest about how you did this that people want to hear about. I noticed early on that you had a comment about the network being 5 lakhs network. Can you explain what that means?
Yeah, and sorry to mention that. I know that the 5 lakhs will not be understood by most of the world people. So this is actually 500K. So 500K we are talking about. Yeah. While explaining, I mentioned 500K. It is in the slides. I corrected it later. I mentioned as 5 lakhs. It's basically 500K.
It's all right. I mean, it's just fun. This is India, right? So it's the numbers are enormous. So yeah. Do you think you can scale to the need that you have in India? Is NSO going to be holding up for what you need?
Yes, certainly. We had same doubt when we started off because this is one of the biggest reconciliation we started off. It's like we knew that certainly we did the reconciliation for 100K, 150K max, which I know of, right? So then we started analyzing the things, mimicking the environment within our local and taking the production copy within our local and try to mimic it and build the service around that. I think certainly NSO adopts it. It's like, that's the interesting thing. It's like, if you give enough core CPU cores and memory, obviously it supports. There is no issue with that. We are almost reconciled 300K plus services at this point in time. NSO keep running. There are no issues.
That's good to hear. When I talk to other service providers about reconciliation, they often talk about how many variants of the service that they found when they started this project. Oh, when we did this reconciliation code, we found so many of these variations of the service. Do you have any sort of metric like that for what you found when you started this?
Certainly, as we have around 5 to 6 different service types. We are supporting MPLS services. They are around 300K services. We have internet services around 50K. And we have SEN L2 services and L3 services around 1 lakh. Like it's nothing but 100K. So basically, it is quite interesting. In MPLS services, we are supporting around 70 variations. We have around 250 plus attributes within a service. This is a huge service which we are supporting reconciliation as well as a provisioning. We have variations in the routing. We have variations in a managed mode. We have variations in the policies. We have variations, whatnot. We have certainly variations of all, right? Routing none, routing AGRP, routing OSPF, routing BGP, routing static. These are all the, like, I'm just mentioning few.
Yeah. So did you see any sort of difference when you started this reconciliation project, when the code first hit the actual values that people had configured manually previously? Did you see a reduction in the number of different variations, or how did you deal with this?
Yeah, certainly this is built over 20 years, right? Even customer involved with many teams, many managers got changed, many resources got changed. Even though there are some deviations we reported in the first cut or the second cut, so the customer came back saying that it's not actually a deviation, it's actually a variation, another variation, right? Let's say it's like there is one example wherein which we maintained in our a standard service, in and out policy should be mandatory thing, right? We found some deviated circuit around 2K, which doesn't have an out policy, which doesn't have an in policy, right? The customer came back saying that, okay, we support such kind of services as well. We have to include them, right? It's like wonderful journey in terms of insightfulness, understanding their network from their perspective and our perspective, and keep growing together.
Thank you very much. There's another question on the chat, but there's no time for that, I'm afraid. So I have to cut here, and we will have to discuss more details around this offline then. We have the app, so we can certainly go on there and discuss all this. I hope you can take the time to answer questions there too. So with that, thank you very much, Grisha, and I hand over to Nicklas again.
Yeah. Thank you, Girisha, for a very nice presentation. I really like the analogy with the elephant having to eat that one. You really have to be determined. So great, and thank you, Jan, for asking the questions. And please continue asking questions on the chat. So we will just play a very short message from your organization, Girisha, from the Cisco CX, before we welcome Nils Petter Tisell up on stage. Nils Petter is NSO Product Manager, and he will give us an update on the NSO future. So with that, see you soon.
Creating an agile enterprise with Cisco CX automation services. We can help you move from manual operations to fully automated. To make it easier, we have a roadmap of automation domains. Here's a functional view of the framework. We've helped hundreds of clients. Here are some of their outcomes. We've had 250 deployments and counting. With 400 SMEs globally, how can we help you?
And welcome to the NSO update here at the Dev Days. Today I will talk about NSO, what we've done lately, what we're doing pretty soon, and in the future. That being said, I will actually start to talk about a little bit how the market have evolved and having a historical view of what we have been automating. So I'll use the mobile world as an example. And we start off with a 3G rollout. At that time, the network were typically co-located, built upon physical devices using dedicated infrastructure. Also, the service definitions were pretty static, with turn-up times in years, and changes took at least months. Moving on to 4G, when the VNF momentum takes off, with data center-based infrastructure that is shared among many services. Still using fixed service definitions, but quicker turn-up times, where we count months instead of years and scale in and out in minutes to accommodate the ever-changing needs of the users. So where we are today with a 5G rollout, we end up in a distributed environment with even more flexible CNFs, container-based network functions, where services are dynamically assembled on demand. Today, the expectations are to be able to turn up services in hours and make changes and updates within minutes. This time journey is similar for other network domains as a physical domain, where we have the traditional use case of VPN provisioning, where everything started as physical dedicated infrastructure with manual provisioning, to the latest SD-WAN technologies, fully automated and fully virtualized solutions. Okay, so where are we then automating? Because I talked about different technologies in different time areas, but bear in mind, automation takes place everywhere. Wherever you have a network function and resources are deployed, automation is done. It is important that cross-domain orchestration is key to reap the full benefits of network automation. Automated networks include not only provisioning of a service, but also the end-to-end monitoring of the infrastructure and service instances. Final but not least, automation provides an abstracted infrastructure layer for service developers and owners, which means that you have one entry point for your service developers and anyone who would like to interact with your network management. Okay, so where is then NSO today? Talk about different technologies and where we automate. I hope that you remember that NSO is vendor agnostic. There was a very long time ago, like 5 years ago, when Cisco acquired Taylor, that the vendor agnostic concept would go away. I think the 170 device integration with our NED technology actually is a very good proof point that we continue on the device vendor agnostic path. So we typically add approximately one new NED per month. And this is a continuously growing catalog while our customer extend the usage of NSO. Our users, our customers, all the top 10 service providers around the globe, we're now also starting to see many of the larger enterprises using NSO, which we're very happy for, mainly in the financial institutions, as well as we see the growth in healthcare, public sector, and other enterprises. 200 customers plus, I think it's more than 200 today. It's a very growing number of customers, and we'll see probably even more when we go into the enterprise space. Also important to remember is it's not only our customers, Cisco customers that use NSO, it's also Cisco ourselves. Many of our as-a-service offerings, such as WebEx or Umbrella, are using NSO to manage and orchestrate their infrastructure. And we also have our sister product, Confi, which is the on-device management application, which is really the same kind of code base that we have in NSO. It's used on many of the device operating systems within Cisco as well as third party. And that's really a way for us to extend the reach of the NetConf Young standard interface, which I will talk about a little bit more later. So what does that mean? So I would like to iterate about how NSO is used in the automation journey. The NSO platform is used to automate any network function, and still remembering that there is an ongoing evolution of automation. We really know that migration takes time, and many customers will run in mixed mode for many years. And to help with the automation journey, the NSO team have also developed the network automation deployment model, where we focus on how to operationalize and set up a network automation organization. This model is really built upon experience from our customers that rolled out automation based on NSO. We do actually have a separate session about network automation deployment model. I really recommend you to listen into that. It's all about the experience of using NSO for real in the field. So that's really the current status of NSO. Let's look into what's happening in 5.4, which is scheduled then for June timeframe, end of June, and we are on time, I would say, because we're pretty soon there. So a few highlights. We have the first off with the multi-factor authentication, many times called two-factor authentication, where we talk about, this is really about adding the capabilities for authentication with third-party authentication systems. So we have our AAA engine that you typically integrate into authentication system. But now, given the increasing demand of more secure systems and secure environments, there was a requirement to actually be able to authenticate via your third-party application, such as Duo from Cisco, which means that when you log in on NSO using your user credentials, you will actually be asked for yet another password or PIN generated out of band, so to say, and then you will be able to log in a more secure way. The implementation itself is really a set of open APIs that extend our AAA agent with challenge response capabilities. And in the 5.4 release, these capabilities are exposed in the web UI via JSON RPC, as well as when you log into the SSO, SSH, and the NSO CLI. Let's move on to the built-in alarm management application that will be available in 5.4. So we have a set of different applications that we continue to grow in NSO Web UI. And here in 5.4, we have the capabilities for the system administrator to actually understand what's kind of in a graphical way to what kind of alarms are happening right now in NSO. It's very focused on the local NSO instance, and it helps you to do the usual suspect tasks, such as list the alarms by severity, understand what kind listing by status, and of course then also acknowledge the alarms and clear alarms. And this is really to give you a one-stop application to understand what's happening with your NSO. Simplified high availability. Of course, we've been around for quite a while with NSO. Most of our customers using HA. And for those of you who actually started to use it, you know about our external package called HEC, which is really an external package or application that's shipped with NSO that manage the HA status. In 5.3, our latest release that we released some time ago, we added some helper tooling to the HEC framework regarding state transitions and restoration of a HA failover. What's happening in 5.4 is actually we're moving in all the state management and operational management capabilities into NSO by extending the NSO core data model. The benefit of this is really that we are then now doing a prescriptive way of actually setting up your HA. We'll also be able to manage the HA transitions and states in the NSO CLI as well as in the various APIs. That being said, virtual IP and BGP will still be delivered externally as a package because those capabilities and tool sets are not really part of NSO. It's shipped with NSO. You will still be able to use the same kind of functionality of HA as you used to do, but it's slightly different there, divided, even though it's much more simpler. For those of you who are worried about your current configuration, we will have the old capabilities in the product for a while, but it will be deprecated, so it will disappear in a few releases from now. Okay, so that was, let's move on to the final highlight about NSO 5.4, and that's about what we're doing with LSA. As you know, we use LSA typically for the larger scale installation, but you can also use LSA to model your device population based on different services in a cross-domain model. We have quite a few customers using it, and we also see that they need to have an easy path forward to upgrade the entire LSA cluster. So in 5.4, you will actually be able to run an LSA cluster with a 5.4 in the top, and then you can have various combinations of 5x and actually 4.7 in the RFS layers. That means that you will be able to seamlessly or more easily in a phased approach upgrade your entire LSA setup. So that was actually the few different highlights of NSO 5.4 that are available here end of June. So what's happening next? What's happening in the future? So let's have a look about that, because we have a release in November timeframe called 5.5, but it's more interesting to understand what's happening in the market based on our customer base. So talked about large customers a little bit. We also understand that when we scale, we also need to improve our performance. I'll talk a little bit about what we think about the performance and what that means for us later. Another thing that's very important, usability. Usability is not only about the graphical user interface, it's the entire experience. We have different uses of NSO, such as the service developer. What is usability for a service developer? It's very much about tooling, about consistency with various APIs and also standardized interfaces. So we are investing very much there to actually give a consistent experience and also make it much easier to start to develop services as well as deploy those kind of services. The same goes for the network engineer that's typically used with CLI. So this makes it easier to actually start to use NSO, but it's also for you that also already have NSO in your organization. We're looking in then to make it easier to actually scale the competence regarding how to use NSO. Interoperability. I briefly mentioned the NetConf-Young. Of course, we are very proud of our proprietary NED catalog, but we have really been pushing for standardized device management interfaces for quite a while, which is NetConf-Young. Now it finally happens in the market. We see a lot of devices coming out now with NetConf-Young interface. That means that we also need to step up and invest in interoperability actions. A few things that we've already done, which is very good to remember, is we have an NSO NetConf-Young interoperability program, which is really driven by helping the market to make NetConf-Young fly and make third-party other device vendors, not only Cisco, but other ones, to can freely join, and they will actually get help to get their NetConf-Young implementation properly verified, so it actually follows the RFCs. Of course, also we do participate in various interoperability programs. Last but not least, we talk about observability. What is really happening within NSO at any given point of time? We talk about three different pillars when we talk about observability. So logs, as many of the other things we talk about here is we do have those kind of capabilities already within NSO. That said, based on the customer feedback, we see how this will evolve. In the domain of observability, we also see the different momentums in the market, such as open telemetry, that we think might be a very good idea actually to align to. So when we talk about logs, today we have more than 15 different logs of different formats, and there we have the exercise actually now to look into what kind of formats going forward should we then support, and what kind of information should we then publish in the different logs. On top of that, we're also looking into how to be even better to actually have unique IDs that you can identify through the different logs. We already started that work with our audit log capabilities, but of course, everything can be improved. When it comes to metrics, the question is, how do I know what's going on within NSO? So metrics is a series of numerical values over time, like number of requests, CPU utilization, memory usage, or similar. But for NSO, what we're actually looking into in the beginning is the CDB logs. If the logs are taken or not taken, number of transactions waiting for the logs, or number of items in the commit queues. And that's something that we see for those really need to be able to expose this, and also expose these kind of data in a way that external systems like Jaeger, Prometheus can consume. Finally, but not least in this topic is the traces, somewhat like log data, but with more metadata and structure. Trace is usually associated with a user request, like a user of a system makes a request, like a netconf edit config operation. Each trace has an identifier and it's further subdivided into spans, which is a concept from OpenTelemetry. But what I'm trying to say here is we do have our traces in place today. What we will do is improve them and also to align to external consumable models that are widely adopted in the market. So this is a very hot area. Really looking forward to the first iterations of this subject we'll see later on this year. Final but not least in our future is I talked about performance. So then you might ask, isn't NSO performing? Well, if you look at this visualizations here, we start from the left hand. Typically where you start to use NSO is smaller environment, hundreds of the number of devices, you can count them in hundreds. The network engineer is starting to use the NSO as a power CLI or a network-wide CLI, which is very powerful and transaction-based, and then move on based on their growth of your device fleet, I would say. Then starting to have devices in the thousands, and then we have, there you actually start to use the capabilities templates within NSO. It's a very powerful construct that you can actually do code-free through orchestrations. That being said, when you go up to tens of thousands, you have the full capabilities of model-driven configuration, all the application tooling, how using Python or Java, and you're doing your Young modeling. We talked about LSA already. That's already in place. We have customers that are running NSO with 80,000 devices in. That's where we are. But what we see is coming up is when we go for the like 5G deployments and other kind of container network function-based deployments where we have more than 100,000 of devices, high frequency of changes, they are virtualized, they are containers, they are very quick up and down based on the demand of new services. So there we're actually looking into how to extend the performance of NSO in these large scale without making a major change in your already known models of actually how to interact and develop the services. So it's more about adding capabilities into NSO to fine-tune and optimize your existing NSO installations, given that you actually already have your service applications in place. This is very good, of course, for large customers, and this will, of course, also be beneficial for all the different sizes of NSO deployments, which is very important to remember. It's not only about performance for the large scale, it's actually will be a tool set for all the different devices, but we start with our large scale deployments because that's where we see the need, the urgent need, I would say, as of today. That was actually the last thing about NSO update and the future. So now it's open for questions, and I actually have help with my dear colleague KJ Rosavik, who will help to answer all of your questions that you might have. Thank you.
Thank you very much, Nils Petter. Very interesting presentation there about the features and roadmap. So we have some questions, and do keep asking questions on the app. The first question is, what 5.3 and 5.4 will deliver in case of performance and resources and footprint and memory management comparing with 4.7, for example?
Okay, very interesting question. And thanks, KJ, for helping out, and also when I'm running around to move around in my building here, since I have a broadband connection problem. Anyway, so two questions there, from 4.7 to 5.2. One thing about memory consumption is from 4.7 or 4x product line to 5x, there have been some significant optimization of how we actually manage the Young model internally. To actually be able to reuse Young modeling space, and this is something that's really is done internal within NSO. So you as a user NSO don't really see it. The big outcome, of course, is you get a smaller memory footprint of NSO. That's one thing that's been improved from 4x to 5x. And then then for the performance, we do have when we're looking into the virtual space where we have NFV deployments, and I know KJ, you are really the product management expert on this, but at our large-scale deployments for virtualization, we have a few big customers that actually pushed us further beyond where we were before, where we improved our virtual network function lifecycle management to actually have a much quicker turn-up time for the VNFs themselves. So that's something that we actually seen pretty recent in both 5.3 and 5.4.
Yeah, and I think maybe one other thing we can mention there is what kind of working the other way is, since NSO 5.x has introduced the ability to have multiple versions of the same NED loaded in memory at the same time, that of course, if you do that, then you will have increased memory footprint because you're having multiple copies of the same NED, and that is one of the factors that drove the optimization of memory usage in 5.x. So next question then. You mentioned how, as an example, how the mobile industry has moved from 3G to 4G to 5G, and moved from physical devices to virtual devices, and then now to containerized or CNF-based systems. So how can NSO be used for managing virtual functions?
So one thing to remember, whatever is physical, virtual network functions or container-based network function, when we look into service orchestration, the use cases are still pretty unique to model the service. So from a functional point of view, that's one of the beauties of NSO. You use the same kind of concepts all over. That being said, when we're looking into the virtual space, we also have a complexity of managing the lifecycle of the VNFs themselves, where we then have our NFVO core function pack, which implements the ETSI specifications. Together with our VNFM, Elastic Service Controller, we actually get you actually have a full stack for managing both the day zero and day one management and lifecycle of the VNFs themselves, and then continue to orchestrate the dynamic services over time using NSO, as you already did in the physical.
Yeah, exactly, and we also have the move towards cloud native functions or containerized functions, and if you watched the recording from yesterday's session, Fredrik Jansson gave a fantastic presentation about the proof of concept work that has been going on in the 5G space, and we're also working towards productization of those orchestration functions. So that there is a lot of work going on both in the VNF and in the CNF space, which is all very, very exciting. So then on to the next question. You talked about observability, and I have been seeing a lot of questions from our customers in that space recently, where I guess our customers now are becoming more interested in looking at how do they know how the orchestration system is performing, and how they can measure and find out when it's running out of capacity, and how to optimize it. So, and one of the questions that keep coming up is related to Prometheus. That seems to be a very interesting technology. So how will NSO integrate with Prometheus and systems like that?
So two things there. First and foremost, of course, we help our existing customers using our existing capabilities. But what I was talking about was really this is a focus. We know that both, of course, the customer need to understand what's going on today, but moving forward, we are then aligning to open tracing that's then going to open telemetry. That actually is then a standardized way of providing feedback to providing data into systems like Prometheus. So definitely that's where we're going, and we're also adding much more granularity to help our customers to actually understand what's happening in the core of the platform. This is typically something we will, of course, see in all our deployments, but then when we go into a large scale, the big ones, this is even more important. And of course, this is also important when you actually develop your own applications to actually be able to understand very easily, quick. So we actually package the functionality we have today into a more standardized data stream, as well as extending the state information, you could say, about the services itself.
Thank you. And you mentioned the large scale there, and I guess that was also a topic of your presentation. So, how do we deal with the very large deployments? But also, I guess, how do we deal with very small deployments? Well, how does NSO manage the span of requirements from very large to very small?
So I think that Grisha had an excellent presentation before this one about large-scale deployment and using LSA, etc., where we have different tool sets to actually scale to massive 100,000 devices. That being said, bear in mind that typically for our service developers, we use NSO on your laptop, and that together with the capabilities of the NetSim, which is basically our NEDs, but they're reversed. You actually have the capability to develop your service on your laptop, deploy it in your lab with small cells, and then do the first production for a few hundred devices. And then you don't really have that much of hardware requirements or performance requirements on your installation itself. It's very lean and mean at the same time that it scales to these hundreds of thousands of devices. So we have both ends there.
Yeah, no, exactly, and I think it's very interesting or very important to emphasize that you don't need to jump to layered service applications. You don't need to jump to clustering. Get as much mileage as you can out of your single server deployment. First of all, by using stuff like the commit queues and the like. So thank you very much, Nils Petter.
Thanks a lot.
Thank you, Nils Petter and KJ. I hate to break you in the middle of this interesting discussion, but keep asking questions on the chat. And before we will see a short message from our partner Devo team, I will just explain the next step a little bit more to help you get further. It's almost like you are attending a real event now. So you're at the stage watching the overview presentations, and now you're supposed to go to the smaller rooms and find your favorite track. So below this video stream, you will find the 3 different symbols. And the next one, number 2, is a live track. So you click on that, and that will take you to the event tab with the live tracks, and you will find links there to the WebExes. And in case you run into a problem having to enter a password, this password will be sent out on a push notification. But the password should be pre-populated, and you should be able to just enter very nicely. So we will now give you a couple of minutes to go to that room and enter your live track. And after that live track, you're ready to go back to your hotel and continue watch on-demand videos for hours if you have energy for that. But don't forget to fill out the event survey on the mobile app. And we really hope that you enjoyed this experience, although we were not able to meet in person this time. So with that, hope you will find your track and see you there.